So continuing our look at polar coordinates, now we're going to talk about how to convert a rectangular coordinate from the x and the y values into the r and theta values for polar form. There are two formulas we'll be using here to perform our conversions. The first one is that r squared is equal to x squared plus y squared. Very important comment to make on using this equation is that when you plug in the x and the y values from the given rectangular coordinate, when you take the square root of both sides of the equation, don't forget that you get the positive and negative answers from doing that. So you should get two answers for r when you take the square root of both sides of this first equation. Next, you use the x and the y values from the given rectangular coordinate, and you do tangent inverse of y over x. Now, if you're doing this from the unit circle, you should notice that whatever value you're looking for, like if it's tangent inverse of 1, you should notice that there are two places where that happens on the unit circle. If you're doing this from the calculator, just be careful because the calculator only knows how to spit out one of the answers. So you have to add 180 degrees or you have to add pi to find that second answer for theta that the calculator is unable to give you. So you should be getting two answers for r and you should be getting two answers for theta. And then the tricky thing here is how do we pick which r value goes with which theta? So to do that, you'll want to look at which quadrant your original x and y coordinates were in. For example, if you have positive numbers for both x and y, then that means you're in the first quadrant. So the angle that's in the first quadrant will get the positive r value, and the other angle that you should have, your second theta value, must have been going into the wrong quadrant. It must have been going to quadrant 3. So what you'll do with that angle is you'll give it the negative r value, and that way it'll flip it back into the correct quadrant, because remember that's what negative r values do. That's what was talked about in the last video. Whenever you have a negative r value, it flips it across and puts it in the opposite quadrant. So that's the way you will in general find two different ordered pairs from a single x and y value. Now I do have a comment down here that each rectangular point, it actually has lots of different equivalent polar coordinates. In fact, there are an infinite number of them we could write. I'm just showing you how to write the two most common ones, the ones that should be occurring between 0 and 2 pi for theta. However, sometimes problems will ask you to write other coterminal versions as well. They may say they want all of the polar coordinates between 0 and 4 pi. So I'll show you that in the examples, but basically it's just going to come down to that concept of finding coterminal angles. Remember that if you add or subtract 2 pi, or if you add and subtract 360 degrees, that just gives you another way of writing the exact same theta value. So if they do give you a different domain than from 0 to 2 pi, you may have to do some coterminal adding and subtracting of 2 pi to find the other versions. Now, if you notice in these directions, this is not what I was describing on the last slide quite yet. I don't want to do the conversion yet. I want to show you the process of finding the coterminal polar coordinates first. So this one has given us one polar coordinate, and they're asking us to find all of the other equivalent ones between 0 and 4 pi for the theta value. So I'm not doing a conversion here. We're just going to find other ways of writing this ordered pair here. Now to begin, I'm going to draw a quick sketch of it just so that we can kind of use that for visually identifying which answers are and aren't the same. So the angle for pi over 4 is this one that's right in the middle of the first quadrant. And by having an r value of 1, that means on the first circle, I would draw my dot right there. So that's the location of 1 comma pi over 4. So one of the first and most important points to remember is that there's always another way to write this coordinate by using a negative r value instead. And the negative r value is going to flip the angle around from the opposite side. So instead of saying pi over 4, the angle that would be on this opposite quadrant, halfway through the third quadrant, that would be the angle 5 pi over 4. So negative 1 5 pi over 4 is one other ordered pair that is equivalent to 1 comma pi over 4, and this angle here is between 0 and 4 pi. So that's one of our other answers. Now that we have these two answers, there are two usually in your interval from 0 to 2 pi, we can actually write some more by just finding the coterminal angles. So if I took this first coordinate that we were given, if we added 2 pi to that angle, then I would still have an r value of 1. But remember, you need a common denominator, so you might want to think of this as 8 pi over 4. So 8 pi over 4 plus 1 pi over 4 is 9 pi over 4. So that would be another way of describing this exact same location, because 9 pi over 4 means going all the way around one full time for 2 pi, plus another 1 pi over 4, and the r value of 1 means drawing the dot on the first circle. So this is another way of describing this point, and the angle is still between 0 and 4 pi. Well, let's also find the coterminal of this one that we did. So I could add 2 pi to this angle, and it would be equivalent to 5 pi over 4. So if I take my r value of -1, and then again, we need a common denominator for adding fractions, so you might want to think of this as 8 over 4. So 8 over 4 plus 5 over 4 is 13 over 4. And if you look at like the decimal value of 13 divided by 4, this is still between 0 and 4 pi. 13 divided by 4 is still less than 4. So that one is also another equivalent way of writing this point, 1 comma pi over 4, and it is still within our requested domain of 0 to 4 pi values. Now if I tried to do the coterminal thing again, if I added 2 pi to this value, for example, so I'll do this in a different color because this one's not going to work. So if I add 2 pi again, it would be another angle that's the same as pi over 4 and 9 pi over 4, but what happens is I end up with 1 comma 17 pi over 4. Well, at this point, we've written an angle that is outside of our range from 0 to 4 pi. So even though, yes, it is another way of writing all of these other ordered pairs we've listed, it is not within our domain of 0 to 4 pi. So I'm going to stop including more ordered pairs. The same thing would happen if I also added 2 pi to this value. That one would also be too big, even though it is still another equivalent way of writing the ordered pair. So these answers are just getting crossed out because we only wanted the angles between 0 and 4 pi. So once you know a couple of your ways of writing the polar coordinate, just remember that you can add or subtract 2 pi, and if it's in degree mode, you can add and subtract 360 degrees to find other ways of writing those coordinates. So here's an example that I was setting up more in the notes with a description of how to convert the coordinate. Now I did include 2 little graphs up here just to help me visualize the location of the points and just to kind of help me check my answers as they go along. So they've given us the rectangular coordinate -1, 1. So if you draw a quick x and y axis, that would mean going left 1 and up 1, drawing a dot. So I'm going to be looking for polar coordinates that end up in approximately that same location because we're still drawing dots in that same position. We're just describing it a different way. Okay, so we have an x and a y value here. So our first step is going to be plugging them into the formulas I gave you on the earlier slide. So to describe what I've written out here, I started off with the formula r squared equals x squared plus y squared. Be careful about your use of parentheses. -1 squared is +1, and 1 squared is 1 as well. So then I added the 1 plus 1 to get 2, and I took the square root of both sides. This is what I was trying to remind you about on the earlier slide. Don't forget that when you take the square root of both sides of an equation, you do get a plus or minus answer. So I actually have 2 different r values here. Then I solved for theta by doing tangent inverse of y divided by x. Well, 1 divided by -1 is just -1. And if you look at your unit circle, the 2 angles where a tangent value has -1 for an answer, that happens at 3 pi over 4 and 7 pi over 4. So now I have 2 different theta values. So the next thing I instructed you to pay attention to on the notes was to say, how do we know which r value pairs with which theta value? Well, since I showed up here in the graph that the coordinate -1, 1 should be up in the second quadrant, one of these angles is in the second quadrant. So for part A, I should be expecting 2 different ordered pairs for my answers, and one of them will use the theta value of 3 pi over 4. The other one will be using the angle of 7 pi over 4. And the way I know which one is which is by noticing that since 3 pi over 4 is in the second quadrant, that's the one that gets the positive r value for an answer. Because remember that if you have a negative r value for an answer, then that causes your dot to flip into the opposite quadrant. You flip across to the other side of the polar graph that you have. So the one that's in the right quadrant, the angle that's in the correct quadrant, give it the positive r value. The angle that's in the incorrect quadrant, 7 pi over 4, would be pointing down and to the right. That's the one that gets the negative r value. So now we have written two different polar coordinates where my angles are between 0 and 2 pi to represent this rectangular coordinate of -1, 1. Once you've gotten these answers, the other parts aren't actually asking you to recompute the entire process. They're just asking you to find the coterminal angles and rewrite them using different numbers for the theta values. So now we'll talk about part B. So for part B, notice that we have a theta value that is between -pi and pi. So this one is still an answer. I'm still going to be using this value of square root of 2, 3 pi over 4, because the angle here is in the specified domain between -pi and pi. The problem is this other angle. 7 pi over 4 is too big. That is bigger than 1 pi. So I need to find a coterminal angle, and since this angle is too big, what I'm actually going to do in this case is subtract 2 pi from it. So remember, for coterminal angles, you can either add or subtract 2 pi, and it just gives you another way of writing the angle. Now, for adding and subtracting fractions, again, don't forget that you need to have a common denominator for this. So you may want to think of this as -8 pi over 4 for a second. My r value is not changing, but if I take 7 pi over 4 and subtract 8 pi over 4, we get an angle of -pi over 4. -pi over 4 and 7 pi over 4 are the same angle, they're just being written different ways. And writing it this way does put it in the specified domain. Now I have all the values between -pi and pi. Because if I tried to do the coterminal process again, if I subtracted 2 pi or if I added 2 pi, it would end up being too small or too big. So I can't do anything else with this ordered pair. Same thing with this one. If I tried to add or subtract 2 pi, it would end up being too small or too big. So we have found all the ordered pairs between -pi and pi that represent -1, 1 in rectangular form. So part C is going to be pretty much the same. The only thing changing here is that the interval has gotten bigger. It didn't just shift where the interval is. Now we have a longer stretch of theta values to consider. So I can't use the -1. That one's out. This first one that we found, square root of 2, 3 pi over 4, that does fall in the specified domain, so we're just going to reuse that value. We also said negative square root of 2, 7 pi over 4 was an answer. We're just going to reuse that value. So we're just writing down all of the coterminal angles with these until we end up with ones that are either too big or too small. So now if I add 2 pi to this value, so the r value is not changing, but if I add 2 pi or 8 pi over 4, this would be 11 over 4. And if you think of 11 over 4 as a decimal, it is less than 4. That's why this is another valid answer. And then I'm going to do the same thing with this one. So keep the r value the same, but find the coterminal angle by adding 2 pi. So 7 over 4 plus 8 over 4 is 15 over 4. And this number is also in our domain. It is still less than 4, so that's why this answer also works. So for part C, we actually ended up with 4 answers. If I tried to do the coterminal thing again, I would end up with 19 over 4. 19 over 4 is too big. If I did it to this one, I would end up with 23 pi over 4. That's also too big. We can't find smaller values that work by subtracting 2 pi because we would end up with negative numbers. So these 4 values are all of the different ways of writing the rectangular coordinate -1, 1, but we've written it in polar form instead. So that's it for the notes. Thank you for watching, guys.